So let's continue our talk about the special quadrilaterals with a rectangle. So as I just mentioned, a rectangle is a quadrilateral. And what makes it unique is, by definition, a rectangle has 4 congruent angles, which would of course mean that they'd all have to be 90 degrees. So a rhombus has 4 congruent sides, rectangle has 4 congruent angles. So first and foremost, that makes it really easy for us to identify the fact that if I consider this side and call this the transversal, then I have these two same side interior angles that are supplementary to each other. Well, we know that that means that these angles must in fact be parallel to each other. And we can use the exact same logic to show that this side is parallel to this side. Again, same side interior angles would be there and there. Getting rid of those extra highlights. Well, let's go ahead and add that to our properties here. And that is that the opposite sides are parallel, meaning that it's a parallelogram. Cool. And now we're going to take a page out of that previous playbook where we're going to go ahead and add in a diagonal and see where that might get us. Well, since these lines are parallel, we can add in our alternate interior angles that are congruent here. So that one's congruent to that one there. And we can do it with the other part here. So this would be congruent to this part here. Again, that's alternate interior angles that allow those to be congruent. And before I forget, let me go ahead and add in some vertices here. Help us describe things a little more easily. So now that we have that, we can actually make the statement that we know that these two triangles here are in fact congruent to each other because of angle, side, angle. And I'm not going to mark it, but obviously this diagonal is congruent to itself and it's in both triangles. So we have angle, side, angle, angle, side, angle, congruence. And so to mark that down, I'm just going to travel from red to green to the right angle. So that's DBA. Okay, and so that was from red to green to the right angle. So start with red on this triangle. So that's B to green, D to C. So now we have those two triangles are congruent, and what's really nice is that means that all the pieces of those two triangles must also be congruent. And again, the reasoning behind this was the angle side angle theorem. And then, as I mentioned before, we know that all the pieces must be congruent. So for example, AD, okay, so AD, that's this one here, must be congruent to BC. So let's mark that down. So AB must be congruent to DC. Cool. So this is all kind of coming together, and I can add that in here as well, is that the opposite sides are not only parallel, but they're also congruent. So just as we did with the rhombus, we're going to go ahead and add in our second diagonal now. And now that we have that in there, well, we can actually get quite a bit more information because we know that the right triangles that are in here are all kind of congruent to each other. So let's go ahead and highlight things up so we can see that a little more clearly. But if we look at this triangle here and we compare it with this triangle here, well, we've got side, angle, side congruence. So triangle ADC, so that was ADC, must be congruent to triangle BCD. Okay, and again, that was the side angle side theorem. Well, since I know that these two triangles are congruent, I actually know all the pieces are congruent too. So for example, this green triangle that I have right here has this little single mark right here, right? Okay, well, that's BDC. So BDC, that's from this one here. Okay, so that's this angle. That corresponds with angle C from the orange triangle. Oh, well, that's right here. So I can just add that in. In addition to that, in the other triangle, or again, in BDC, I have this red mark here. Well, that has to correspond with this one here. awesome. And the really great thing about this is we could do the exact same thing with these other triangles here and here. So by the same exact logic, I now know that this angle must be congruent to this angle, and that this angle here must be congruent to this angle. And from there, we can show quite a bit more about the diagonals and then some additional information about all the congruencies here. So one of the last things that we want to show here is that if you look at this, there's a lot of symmetry and the diagonals look pretty darn close to each other, don't they? Well, we actually already know that they're congruent because these two triangles are congruent, right? And so AC must be congruent to DB. So we actually can put that down already. The diagonals are congruent. So now what we can do is we can look at the fact that this triangle here and this triangle here, and we could have done it with the ones on the sides as well, but it's not necessary, are in fact congruent. We have angle, side, angle congruence with both of these triangles, and they're isosceles. And so from all of that, it's pretty easy to make the jump to the fact that this side here is congruent to this side, which is congruent to this side, which is congruent to this side. It's all congruent based off those two facts. One, we know that AB, and let's call this E here, that triangle ABE must be congruent to triangle CED. Okay, and again, that was because of side angle, side, angle. And we know that both of these are isosceles. And so since they're isosceles, and we know they're isosceles because of these base angles here, we know that all those sides must be congruent. And we can add that in and we can say, well, that means that the diagonals, in fact, bisect each other. And there you have it. You have your properties of a rectangle. But I'd encourage you not to memorize this list. Not to say you can't familiarize yourself with it, but use this diagram here. This diagram has all the information you need. And if you can really just remember that this is a bunch of isosceles triangles, really, if you can just remember that you end up with these congruent isosceles triangles kind of catty-corner to each other. If you can do that, you're going to be able to find all of the information that you need in these diagrams. So again, try to understand, not necessarily to memorize.